It's time for a little bit of rationals review. This is something we do in groups, but I figured, why not record a video, because we got a group right over here. Mr. Allen, Riverdog, Jenny, she's snuggled between two pillows. She's no longer scared of the thunderstorms. She's gotten out of her hiding spot and found a new hiding spot, I guess. So let's hop to it. We're going to go ahead and graph one of these. We haven't done one of these in a while. So what's the first step when we're going to graph a rational function? I'm going to factor everything. Okay, so let's go ahead and do that. I'm going to have that over to the side here where I have a little bit more room. So I would have, there we go, f of x is equal to, I don't have to do anything in the numerator. In my denominator, that's going to factor to x plus 5 and x minus 1. So nothing is going to cancel, which means I don't have any holes, but I am going to have a couple vertical asymptotes. Let's first... let's get that domain going. X is all real numbers except x cannot equal -5, +1. Lovely. Ooh, slight voice crack. I'm going to leave it, though. I'm going to leave it. All right. How about x-intercepts, our zeros? How do we get those zeros? Well, that's when, if I plugged in 0 for y, if I set my equation equal to 0, how would I get it to be 0? Well, I would need my numerator to be 0, so I'm going to do that in orange, and then we can see our work pair up. So I would say this is 0. I don't want my denominator to be 0 because then it's undefined. So I would have to do x plus 3, so I'm going to get x equals -3. So I will have -3, comma, I need a 3 there, 0. Excellent. How about my y-intercept? Well, my y-intercept would be when my x's equal 0. I'll change colors. So I'd have all of them being 0. 0 plus 3 over 0 plus 5. And you know what? Better yet, why am I doing that? Let's just look at our those two right there. I'd have 3 divided by -5. There it is. So 0, comma, -3/5. Right, because if I plugged in 0 for all my x's, they would all go away. I'd only be left with those two constants at the end. Nice. Keep moving. Keep grooving. My vertical asymptotes, we already mentioned those. They would be x equals, it's what's left in the denominator, -5, and x equals -1. Sorry, +1. Jenny spoke up. I don't know if you heard her. She's like, yo, Dad, it's +1. All right. Holes, none. Nothing canceled, no holes. Horizontal or oblique asymptote. Well, I have a degree that is smaller in the numerator than the denominator, so it's going to be y equals 0. No side work, so I'm going to keep the same color. And then let's go ahead and start graphing this, and then we'll deal with the end behaviors and all that. All right. So I'm going to get my vertical asymptotes on there, and my horizontal asymptote. I'll do that with the video paused. So there we go. There's our asymptotes. We got x equals -5, x equals +1, and y equals 0. It's always a little hard to see the y equals 0 when you have that. And then I've got an x-intercept of -3, 0. Right there. That's weird. It's on the asymptote. Oh, wait, that's right. You can cross a horizontal or oblique asymptote. Okay, so remember that. Because that could be a question that we ask. True or false? You may cross a horizontal asymptote. True, you may. Or it might say, what can you not ever cross? You cannot cross or touch a vertical asymptote. These are multiple choice type questions or true-false type questions we can ask on a test that will be able to assess your understanding of rational functions without actually having you do an entire graph. Okay? Let's continue. My y-intercept, I did that in purple, so I guess I'll do that in purple again. 0 and then -3/5, which is just like -0.6. So I'm going to go with that right there. Wonderful. So I can see, I think, about what my graph is doing here, or I'm starting to see it anyways. Anything else that we have that we can use? Doesn't look like it. Okay. So what I'm going to do is check out what's happening near these asymptotes so I can get a better understanding of the graph. And I'm going to do my graph in green. Okay, I like it. So when I do that, let's go with a value that's, I'm going to deal with this middle part right here. Since I already have points, I kind of want to see what's going on in this area. If I plugged in a negative 4.9, because that would be real close on this side. Negative 4.9 would be negative, positive, negative. Negative, positive, negative would be overall positive. So I know I'm doing this up here. And then let's see, does it continue down here? Does it loop right back up? Well, if I go with with a 0.9, a positive 0.9, I'm going to have positive in my numerator, positive, and then negative, because 0.9 minus 1 would be negative. So that's going to be overall negative. So I'll go ahead and pop a down arrow right here, and it's going to look something like this. Whoa. It's a little shaky there, but we're all good. It's tough on this angle of the screen sometimes. All righty. Now that we have our center portion, let's get the other parts. If I go over in this area, is it going to be doing this kind of a thing, or is it going to be doing this kind of a thing? Well, because I don't have a multiplicity of 2 for my vertical asymptotes, I do know it's going to be over here, but we can also do a quick sign check. If I plugged in negative 5.1, if we weren't sure, if we didn't remember that, I'd get a negative in the numerator, a negative for this factor, and a negative for this factor. So 3 negatives is overall negative. So I do know it's looking something like this. And then same idea on the other side. I do know it's going to be up here in the first quadrant, but we could also do a check. 1.1 in there. I get positive, positive, positive. They're all positive. That means that it's going positive on that side of the vertical asymptote. Excellent. Let's talk end behavior. We've got the graph. It looks beautiful. It looks fantastic. I could even label my vertical and horizontal asymptotes if I wanted to get fancy. X equals negative 5. X equals 1. Y equals 0. Oh, the person that's reading this graph, because somebody's totally going to read this graph and be like, this is great. Thank you so much for labeling all that. It's so wonderful. Okay, let's continue. End behavior. As x goes to infinity, as I'm moving to the right, what is y approaching? Well, it's approaching that horizontal asymptote of 0. Woo woo. We're looking at our horizontal asymptote for these. As x goes to negative infinity, I'm going to 0 once again, right? I'm getting closer and closer to it. I'm not touching it. I'm just approaching it. We can cross our horizontal asymptotes. It doesn't do that on these sides, only in the middle there. All righty. How about approaching the vertical asymptotes? Wonderful. Hey, if you look down here, you would see one of our vertical asymptotes there already for us. Gave you an answer. How nice of us. All right. As x approaches negative 5 from the left, that's what that little negative means. What is y approaching? Well, from the left, this left-hand side, it's going to negative infinity. Nice. All right, we looked at the graph. We did our sign chart as well. You could have done the sign chart. You could have done negative 6. Could have done negative 5.1 like we did. All right, we already did that, though. And then as we approach it from the right, well, we can look at our graph that we have, or think about that sign chart as well, and we knew that it was approaching positive infinity. How about as x approaches the other one? So that was positive 1 from the left. Y approaches from the left side, it's going to negative infinity. Again, we already did the sign charts a little bit ago. We just did them in our head when I was over here with the mouse, with the cursor. And then as x approaches 1 from the right, that's on the right-hand side here, whoop, we're going to positive infinity. Y approaches positive infinity. I like it. Excellent. Bonus math. Let's keep going. Actually, before we keep going, there were a couple other questions I figured we could ask. So if this were, I could just give you this function as a multiple choice and say, what are my vertical asymptotes? Boom. There's a multiple choice question. What is my horizontal asymptote? Boom. There's a multiple choice question. What is my y-intercept? Free response or multiple choice question. What are my x-intercept, or what's my x-intercept? There you go. Multiple choice question once again, or free response. So we can ask individual questions like that on a multiple choice or a short answer portion and not actually have you graph it, but there's a handful of questions there that we can ask in this situation. Or as we can even ask these types of questions as a free response as well. So be prepared for that, to see all these questions asked in an individual way about a rational function without actually graphing the entire thing. Okay, so be prepared for that. All right, a few more questions here. Given r of x below, function r of x, solve r of x is greater than or equal to 0. Lovely. I like it. Excited. Let's check out the graph. Why won't it select the marker? I'm going to go with red. Okay. So we want to know, when is it greater than or equal to 0? And be careful when reading these graphs. As I was looking at this, I almost read the wrong numbers. Our vertical asymptote is at x equals -1. X equals -1. Okay. So when is it greater than or equal to 0? That would be when it's above my x-axis, on or above my x-axis. So that looks like we are at -2 right here, including it. And then we're going to -1, but not including the vertical asymptote, right? Not including that vertical asymptote. It can't be there. Union, when is it positive again? Well, it's all negative down here, but at, looks like +2, including it because it's greater than or equal to, onto infinity, and we cannot include infinity. Only Buzz Lightyear can go to infinity and beyond, but not us. Sorry. If you were to write this, well, if we were going to do it in interval notation, that's how our test would likely ask it. You could use inequalities if you'd like. It'd be -2 less than or equal to x less than -1, and then x is greater than or equal to +2. Either one's cool. In a Google form, we would ask it in this way just because it's easier to type in with what you have. All right, with your keystrokes you have. Lovely. Let's keep moving. How about this one? Solve graphically. Perhaps we shall graph this. So I've got my graph. Let's see here. It looks like it's going to be a positive cubic function. I've got my my intercepts down. Now, what happens at -2? It's going to go through the graph, and at +5, it's going to bounce off the graph. It's a positive cubic, so it should look something like this. So I just need to get that to fit the mold, and maybe I'll even pay attention to what my y-intercept would be. It would be, if I plugged in 0, I'd get 25 times 2 is 50. So I'll think about that and label it. Whee! So that's going to be 0, 50. Not that it's really important for this problem, but just out of best practice, I'm going to label it, because that's a great review of polynomials. I love review. All righty. When is it less than 0? Strictly less than. It is strictly less than only in this portion down here. It's only where it's less than 0. So my answer for this one would be when it's -infinity to -2, not including 2. There's my answer. Or you could say x is less than -2. That's another acceptable answer there for that one. Now, if I wanted to, let's do a little quick what if. Glad I hit the pause there. I had to sneeze real quick. Sorry about that. But anyways, let's do a quick what if. What if this was x plus 2, x minus 5 squared is less than or equal to 0. Then what would we have? Well, that would be still this portion, but it's also equal to 0 right there. So what I'd have is from -infinity to -2, including it. It's a weird bracket. Union +5. Bippity bop. Okay, so that would be my what if there. And I could write that with an inequality as well. X is less than or equal to -2, and x is equal to 5. I like it. So not that it was that problem, but I think that's kind of a special case when we have just that single point there. So I did want to bring that up. All right, now it's time to write the equation of the rational function below. Let's do it. So let's say I've got, I'll start with a little y equals action. I like to look at my my vertical asymptote first, so I'm going to make a fraction. And since my vertical asymptote is x equals 5, I'm going to have x minus 5 as my factor in the denominator. Then I'm going to look at, so I got a horizontal asymptote of y equals -2. So that means that my degree in the numerator and denominator need to be the same. So I'm going to have some x factor up in the numerator. But I'm also going to look at my x-intercept of -5, 0. So that means I need to have x plus 5 up here in order to get that x-intercept. Now, the other thing to consider, again, is back to our horizontal asymptote. I have like numerators degree-wise. So that means I'm doing coefficient over coefficient, which would be y equals 1 at this point. I don't want that. I want -2. So what if I were to just throw a -2 coefficient? So now what I have is a y equals -2 for horizontal asymptote. I have -5 comma 0 for my x-intercept. I have x equals 5 for my vertical asymptote. And if I were to plug in 0 for all my x's, what would we get? Well, then I would have this. I'm going to change colors for it. If I plug in 0 for my x's, I get -2, 0 plus 5 over 0 minus 5. So I'd have, that's 5 times -2 is -10 divided by -5. That gives me +2. That's what I got right there. Woo woo! I did it. And you did it too. Be proud of yourselves. There is my rational equation for that graph right there. Uno más. So the last one here, we're going to solve algebraically by using a sine chart. Excellent. Let's go for it. Well, first thing I like to do is I like to pop down my critical values, and I like to label what they are. So my critical values in this one, I'm going to have x equals 0. I'm going to have x equal, and that is, let's see, that's going to be a 0. I'm going to have x equals 3. That's going to be a 0. And then I have x equals +2, and that's going to be a vertical asymptote. Excellent. Number line time. So I have 0, 2, and 3. Excellent. Let's put down some test values. Test values will be in orange. So I'm going to go less than 0, which is -1. Between 0 and 2 is 1. I got 2.5 here, and I got 4 right here. Remember, we're just worried about positive or negative. So when I plug -1 in, I'm going to have a negative over a negative, which is overall negative. Then for my 1, I'm going to have a positive for the x. I'm going to have a negative when I plug it in with the x minus 3. And then I'll have another negative here. So that's overall positive. If I plug in 2.5, I've got a positive out front. It's going to be whatever that number is, right? Because it's just x. And then 2.5, that's going to give me a negative. And then down here, I'm going to have positive. So negative. And then lastly, if I plug in 4, I'm going to be positives all around. Everything positive. So I've got a positive overall. Wonderful. Now let's go to what this is asking here. And I almost forgot again. This is a 0. 2 is a vertical asymptote. And then 3 was a 0. Definitely something we want to jot down. So now we want it to be greater than or equal to 0. Well, where is it greater than or equal to 0? That would be in right here and right here. So let's see here. When we write this, since 0 is a 0 and I'm greater than or equal to 0, I will be including 0. And then since this is a vertical asymptote, glad I wrote that down, I'm not going to be including the 2. Then I will join back up, union back up at the 3, which is a 0. And I'm including it because it's equal to 0, not just strictly greater than. And then on to infinity. Beautiful. Excellent. So as far as how we could ask this on a test, I could just have you do a full-on sine chart. I could give you this completed sine chart saying it's negative, positive, negative, and positive, and then ask you to tell me where it's positive, which intervals it's positive on, or which intervals it's negative on, right? I could just ask you to read a sine chart that's already been completed for you. So there's ways we can break this stuff down to ask it in different ways on a test, so please be prepared for that. Bippity bop, there we go. We're good to go. I'm just going to leave it in interval notation. I like it. I prefer that over the inequalities. So hope you guys enjoyed it. I know I enjoyed it. I know River Dog Jenny also enjoyed it because the thunder has stopped. So she's happy. She's a happy camper. She's just napping, though. All right. Have a wonderful day. Enjoy. America, freedom, rock and roll, Costco, River Dog Jenny.